So, Wyatt, I know I have a big voice. This is one of those times when it really works well. Not so well in, like, at a restaurant where I'm always being told to lower it. Okay, so before we get started today, several important announcements. First of all, there's no class on Thursday, and the reason is it's engineering day, and the engineering college actually cancels all undergraduate classes in the engineering college. That doesn't mean your gen ed classes are canceled, because they're not, but and actually if one of your other engineering professors says that he or she is holding class, then they are, but we've been told we need to cancel, so we do. However, there is still a video lecture for Thursday and some participatory activities for you to look at. And the reason I have to do this is because the fall semester is already shorter than the spring semester. The spring semester is 15 weeks. The fall semester is 14 and a half weeks. When the engineering college makes me cancel a class, that reduces the semester further to 14 weeks. And we can't really drop material. So I can either try to rush through more material in less time, or I can do what I do, which is I have a video lecture from another semester and have you treat it as an ordinary class. Just you'll view it at some point on your own. So please do look at that. It's an important lecture because it starts the linked data structures. You'll notice you should start at the 7-minute and 15-second part. Before that, it's talking about an exam from the previous semester, so that's irrelevant. Make sure you complete the participatory activities by Thursday at 9:30, but you don't have to look at the lecture itself until next Tuesday, so you can look at that at your leisure. So if you're participating in the engineering day activities on Thursday, no problem. You don't have to watch it on Thursday. You can watch it on another day. Okay, so we clear on that? There is a video lecture to view. There are pre-class participatory activities, but no scheduled class Thursday. Okay, second thing, notice that for today was one of the few times there was no pre-class activities, but there is a post-class activity on Code Assessor, and that problem was just published, so you can go to that and do it after class. I have to check and make sure that the write-up is available. If the write-up's not available, I will make that available right after class. I remember now I need to check that. Third thing, we have an exam coming up. Usually I talk about it a week from the exam, but class is canceled on Thursday. So we have a exam, second midterm, coming up on Thursday, November 1st. And the lab portion, the coding portion, will be in lab next week. So just like last time, same format. So in the lab, you'll have a one-page cheat sheet front and back. No such cheat sheet in class. Paper version is covering everything up through what we cover on Tuesday. On the coding portion, it will be up through everything that we talk about today. So sets and maps will be fair game, but how you implement them using linked data structures will be something for the coding final. Now, you will be expected on the paper portion to be able to, for example, draw the linked data structures. So on the paper portion, you're responsible for everything up through Tuesday. So questions about that? Yes? It is due in 2 days, like it normally is, so Saturday at 9:30. I'm sorry, gosh, my mind's not working. Thursday at 9:30. Okay. Other questions? Final thing, just because I gotten another query about it, wanted to make sure that it was clear that the final, even though, so the final, is slotted into the 8 to 10 time frame. Because the final is like a midterm, the paper portion will only take an hour 15 minutes. So because it's generally, not all of you are early risers, I'm pushing the start time to the latest possible point. So the final exam will start at 8:45, not at 8, but it will still end by 10. So if you have an exam at 10:15, don't worry about it. The exam will be over at 10, okay? So just wanted to make that super clear, because before it was clear that it started at 8:45. It wasn't clear that it ended at 10. Okay? So those are kind of the pre-class. And one final thing on the lab. This is a new lab, so there were some lab glitches. They've been fixed. There was a post from Clara on Piazza. So it was post number 2, let's see. It was this one regarding the Lab 6 input write-up. So there was a couple issues with the lab write-up. One was that when I did the example for the lab write-up, it was based on running the executable on my laptop rather than on the Hydra machine. So the example wasn't lining up with what the output you were seeing on the Hydra machine. It does now. I rewrote it last night. I reran it on the Hydra machine. So the example in the lab write-up is now consistent with what you see on the Hydra machine. And the important point is that random number generators are different on every different operating system and machine. So in order to replicate our results, you need to run it on the Hydra machine, because we'll get different random numbers even with the same seed on different machines. The second thing is that in order to match the grade scripts, you have to generate the random numbers in a specific order. And again, I've changed the lab write-up to make it clear what that order should be. So if you go to the lab write-up and then you go to random number generator, whoops. So makes it clear that the order you generate your random numbers, you first generate a random number to select the candy. Second, you generate a random number to select the length of the candy sequence. So if you do it in the other order, it won't match the grade scripts. And finally, you should be using the rand function to generate your random numbers. If you use another one like LRAND48, then you won't get the right random number generators. I'm sorry, right random numbers either. Let's see. The post by Clara was saying that you could generate your random numbers between 1 and 100 inclusive. On the lab write-up, it said 0 to 99 inclusive. I really don't care whether you do it between 0 and 99 or between 1 and 100 like she did, but there is an important thing. If you do it between 1 and 100, then you have to use less than or equal when you're comparing with the cumulative probabilities, whereas if you do it with 0 to 99, like I suggested in the lab write-up, then you use less than. So you just need to be careful about that slight nuance. Okay. So, and if you have, apparently this filtered back to me through like fourth-hand information. I really appreciate it if you are confused about something to post it to Piazza or send me some email, because it really helps me to get the write-up clarified, especially in this case where it was the first time this lab was being used, and there's always going to be some things that are clear to me because it's in my head, but it's not clear to you, and definitely helps for me to get that feedback so I can clarify it. Okay. Oops. So today we are finishing up with sets and maps, and we're also going to be giving you more work with big O so that you can really start to think about efficiency. So we're finishing up with sets and maps, also talking about using maps as associative arrays, so doing both things. One thing I did look up was what suggestions there were about using, if you remember that there was count versus find, so with both sets and maps, they had an operation, either you can use insert, or with maps there was a function called in place. That's maps only. And with there was a find, but there was also a count function. So I looked it up. The recommendation is that you use find if what you care about is finding an element. You use count if what you care about is the number of keys that exist. Count apparently was really introduced for multi-sets and multi-maps. It appears that count is there to allow you to count the number of duplicate keys. But to keep things consistent, they also added count as a method for maps and sets. Find is more efficient than count. So that's why you should be using find unless all you care about is the number of keys. The reason, especially with multi-maps and multi-sets, is that find can stop as soon as it finds the first key in the set or the map that matches the key you're trying to find. Whereas count has to keep iterating until it has exhausted all of the duplicate keys. So count will be slower because it will keep iterating, trying to see if there's other duplicate keys. So find is more efficient. It's also better from a documentation perspective. So find says exactly what you're trying to do. You're trying to find the key. Count does not actually say what you're trying to do normally. Normally with count, especially the way the book uses it, you're trying to simply find the key. You're not trying to get a count. So the recommendation is that you use find and not count. Okay, with in place, in place is definitely more intuitive because it allows you to provide two arguments, a key and a value, whereas insert is less intuitive because it forces you to use the make pair command. Does anyone know what the issue is with in place? Yes.
I mean, I don't know what the issue is exactly, but I think it worked whenever I started.
Okay. So that's the issue, but we now will. Someone's going to give us the reason. Yes. Very good. It's only in the C11++ standard. So the reason you couldn't make it work is that the Hydra compiler won't do it unless you create a flag use a flag to say to use it. And that flag is you have to say STD. So dash STD equals C++ 11. And I've asked Clara to change the grade scripts so that it works. They work with C++ 11. She claims they already did. Someone else claimed they didn't. So I'm not sure. She claims that several students had already passed the grade scripts with C++ 11 code, but I know another student claimed it didn't work with the grade script. So I've asked her to check into it because I'd like you to be able to use the C++ 11 standard if possible. So at any rate, if that's general, the thing is you need to use that flag on the Hydra machines in order to get that to work. Okay, but you should also be aware when you use it, it means that your code isn't as portable because there are compilers like the one on the Hydra machine that by default won't compile it properly, which is annoying because the standard is already 7 years old. Okay. So let us, without further ado, then get into things. So at the end of the last lecture, we were basically our running example is we have this roster text file, but not there. And it has a bunch of people with last names in it. Specifically, it's the last names of NFL players, I think in 2009, but that's not really important. And what we're doing is generally counting the number of players that share a last name. So for example, Adams, there are 7 players that share the last name of Adams. So that's kind of our running example. So just to refresh your memory on what that looked like with a map, we include the map using the include statement. Then we are storing the last name as the key, so that's the string, and the count of the number of players with that name is the int. So we first read the first and last name, then we try to find the last name, and if we don't actually, then we have returned a pointer to the sentinel node. And in that case, we insert a pair with last name and the count set to 1. Otherwise, we increment second by 1. Now remember, what you get back as the return value is a pair. A pair has 2 fields. First is the key. Second is the value. Okay? So we are incrementing the value. And notice what you get back, in effect, is a pointer, so you use the arrow as opposed to a dot. So that allows us to do the count, and then at the end we iterate through our map, and because the names are stored in sorted order in a map, they will come out in sorted order. So questions about that example? That's kind of where we left it on Thursday. Okay. What I wanted to do is show you a couple other ways that you can use maps and write this code just in a somewhat different way. So the first thing is that you could simply is knowing that the insert returns a value. Okay, so the insert returns a pair. And that pair that's what's returned by insert. The first thing is a pointer. Actually, we're using Firefox. Let me go to Chrome so I can write over this. So hold on one second while I get down to that. Okay, so again, here's our iterator. Let me show you what those values mean. So this one is a pointer to the inserted item, or, this is important, if the item pre-exists, or item already exists, a pointer to that item. And the bool tells us whether the insert succeeded. And the insert succeeded if the item was not already there. If the item was already there, the insert fails. Okay, so succeeds, it succeeds if, whoops, oh no. Okay, need to get rid of that line. Okay, so it succeeds if item not already there, or was not there previously, or the item did not already exist. Okay, so the insert actually tries to do a find, and if the item is already there, the insert fails, it returns false for the bool, and it returns an iterator that points to that pre-existing item. Otherwise, it inserts the item and it returns a pointer. So how is that valuable to us? How can we make use of that in our find or in our counting problem? So let's go back and take a look at our counting problem. So we did a find, and then we check to see if the find succeeded, and we do two different things based on that. Now I'm saying that insert gives us all the information we need to do, and we don't need to do a find anymore. Okay. So what I'm going to do is change this find here to an insert. And what that's going to do is it's going to give me an iterator. One way or the other, I'm going to have an iterator, right? So I can then go ahead and do something with that iterator based on whether we created the new item or not. So I'm going to go to my map. Okay, and I'm going to change it so that I am going to do a result. So you'll notice, first of all, I have declared a result so that it's a pair. So I'm getting back an iterator, and that iterator, I have to specify the type of iterator. It's a iterator to a map that has a string as a key and an int as the value. So I'm going to say result equals names.insert make pair last name 1. So if it succeeds, I'm in good shape. It already did the insert. If it fails, then I simply need to take whatever iterator I got back and increment it. So what I'm going to do is check the result. and I am going to say if result dot second, and we'll see if that dot works. So if it succeeds, we don't want to do anything. So what we care about is if it failed. So if not result dot second, then what happened is the search failed, or the insert failed. Insert failed, the item already, or the name already exists. So this is a good place for a comment because it's not exactly clear from looking at the code what we mean when we say not result dot second. So we mean that the insert failed and the name already exists. So what we can do at this point is simply now take the result dot first, and we are going to increment second. I know this doesn't look great. Okay, in fact, it probably looks pretty confusing. So what is happening is result dot first is returning this iterator. And then we are taking the second value, which is the count field, and incrementing it by 1. Okay, so that is what is going on here. Kind of obviously a bit confusing. You could certainly, I would not blame you if right here you were to do something like, say, int iterator mit equals result dot first, just so that it's clear that what's going on, and then you said mit second, because otherwise this is a really confusing piece of code. But does everyone see what I have done here? I've used the insert method and completely eliminated the find method. I've taken advantage of the fact that the insert method, if it fails, will return an iterator to the pre-existing object. Okay? So this is actually more efficient code because I am only doing one order login operation. Both find and insert cost me login. So instead of doing 2 operations, a find followed by an insert, I'm just doing 1 operation. So that's another way you can do it. Now let's just compile that and make sure it works, because it's always a good idea after claiming something is good. And it's not liking it because I'm also using, yeah. Sec, I got a 4. What am I doing here? Why does it think I'm calling min? Mit shouldn't have an undeclared. I've made a very subtle mistake here. Easy to make. So this is actually instructive. So it's telling me that use of undeclared identifier mit. Did you mean min? Okay, so it says this is undeclared, but let's go and look at my code. I declared it right here. Yet it says right here that mit is undeclared. You all will get this error at some point in your career. We have 50 eyes in here. Can one of them see what I did wrong? Why is mit undeclared on the second line when I clearly declared it right before it? Yes. Very good. I'm missing an open brace right here. Notice that when I put the comment in, there's no left curly brace. C++ does not give a hoot about how I indent my code. So the fact that I indented MIT second right under the declaration for MIT doesn't matter. By forgetting the curly brace, I was saying that the if had only one statement, and that was this assignment to MIT. This second statement is executed unconditionally. It is not part of the if. In fact, if I did a GG equals G, look what happens. It moved that MIT over because it's always executed. Now, this was supposed to be a closing brace for the if statement, but it's now a closing brace for the while. And everything is off. Okay? So, all because I forgot one curly brace. It messed up the rest of my program. So, that was a very nice instructional moment, even if a bit embarrassing. And now it all works except for the warning. Okay, and if I run it, because we should also run it, make sure it works. I always give atoms a look because I know it's 7, and certainly looks right. So that insert is one way to do it. Now, here's another way. Okay, you read about it today. So in the lead up to today, you read about using maps as associative arrays. And the book had it kind of as an afterthought. So the STL overloads the array square braces operator. And you can use the square braces to find a value. So you put the key in the square braces, just like for an array, you put the index that you want, and what you get back is a value. With a map or a set, what you do is you give it the name of the key, and you can either assign a value to that key, or you can retrieve a value. So I'm going to change this once again to the easiest and most nice looking one, which is I am going to say that names of last name plus plus. Look at that. Is that not elegant? One line. So what that is doing is it is finding the last name, and it's saying return the value. If it does not exist, if the last name is not yet in the map, then C++ inserts it automatically and assigns the default value for that type, which for an integer is 0. So if it did not exist, then it inserts last name into the map, and it returns 0 because that is the default value. I then increment it by 1, and voila, we have the right value of 1 for a new last name. And if it already existed, then names ln returns the previous value, the count for that last name, and we increment it by 1. Okay, that is really nice. Very simple. I love it. Be super happy if you write it that way. Now, what do you think the default value is? If so, for an integer, it's 0. For a float, it's 0.0. What do you think the default value for a string is? It's important you know this. It's not the null string.
Blank string.
Empty string. Yep, blank string. Empty string. Yep, empty string. Okay? For a char, it's the empty char. I haven't tried it for a bool, so I'm not sure whether it's true or false. My guess is false because 0 would be default, but I'm not sure. Here's the $64 question. What do you think the default value is for a class? If the default value is a class object, what do you think the default value is? Like if I have a person class, Well, it can't be a null pointer. If I put in, it can't be zeros either. So if I have a class, person, blah, 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 and I say map string person, very good. And what kind of constructor specifically do we think is going to get called? The default, which is the zero argument constructor. So you have to provide, it's not going to work if you don't have a zero argument constructor, because to create a default value for a class, it's going to need a zero argument constructor. So if you haven't, remember, if you've provided any constructor, the default one goes away. So you have to be very careful that through hook or crook, there is a zero argument constructor available for C++ to use, because that's what it will invoke in order to create a default instance of a class. Yes, John? Yep, so here, let me change this back. Well, yeah, so we're going to get into why this behavior isn't always what we want. But in this case, it is exactly what we want. If the last name is not already in the map, we want it put into the map, right? And we want its count to be set to 1. This does the trick. If it's not already in the map, it inserts it into the map, it returns 0. And then I increment it by 1, which gives us 1, and that's exactly the right result. Okay? It returns the value. So what you put in the square braces is the key that you're looking for. What you get back is the value associated with the key. Okay? That's what happens. So don't just take my word for it. Let's compile it. There's the obligatory warning. We run it. Take a look at atoms. This is always my quick check. It's 7. Everything's in order. We're good. Okay, so this is a powerful and very nice way of both retrieving and potentially inserting. Okay, so you should feel free to use this notation for retrieving elements. So basically, when I say something like names L of n equals something, that is basically like an insert or an update if the item pre-exists. Okay, if I say something like x equal names L of n, that is like a find. Okay, it returns the value associated with the key. Okay, if you want to do delete, you have to use the erase method. You can't get away from that. But insert and find are very nice. Now, let's talk about the pitfall. I'm going to show you an example what you have to be careful with. And the pitfall is right here. It's an update if the item pre-exists. And it is actually, it's not that. It inserts it if it doesn't exist. So here, if the item doesn't exist, it's going to insert it and return the default value. So this is a big warning. Danger. What was it? Danger, danger. I forget what the rest of it was. But at any rate, danger, danger. If the item does not exist, then the item, or if the key, let me be more clear, if the key does not exist, then the key is inserted into the map and the default value. That may not be what you want. You may actually be wanting to determine whether the item is in the map or not, and if it's not in the map, you want to do something different. And you might say, well, just check to see if the return value is the default value, and if the return value is the default value, I'll just assume the find failed. You can't do that. The default value is a legitimate value. That's just the same reason why we tell you you can't use A to I and A to F if 0 is a legitimate value. You can't determine with A to I and A to F if the conversion failed if 0 is a legitimate value, because now there's ambiguity. Was 0 the integer that was provided, or did the conversion fail because an integer wasn't provided? Same thing here. You can't just assume that because find returned the default value that the find failed. The default value is a legitimate value. The key may have pre-existed and had the default value. So you have to be very careful when you use a map in this way. Okay, and in fact, Dr. Planck gives an example. So he now switches over in his associative array notes, he does golfers. You will find out if you take 302 or if you ever take Dr. Planck loves golf. So in this case, Dr. Planck was looking at the 4 so-called majors in golf. The British Open, the PGA, the Masters, and the US Open are the 4 major tournaments held each year. And what he's trying to do is calculate if a golfer participated in all 4 of the so-called major tournaments, he wants to compute their score in that tournament. Okay? Or at least that's eventually going to be his goal. Okay? In the first part of it, I think he is simply reading the scores from the 2009 Masters tournament and printing them out. So what he is doing is he is reading the score and the name, and then he is getting the rest of the line. Okay, so if we look at his thing, what he has is the score, then the first name, and then the last name. And let's see if there's any one where there's a third last name. Okay, we don't have anything like Brad Vanderzand in here, but the issue is that once he's gotten the first name, the last name can be arbitrarily many last names. So what he's doing is he is reading the first part of the line with this statement. He reads the score and the first name. With this get line, he's reading the rest of the line. Now, this is important because some of you have been trying to mix and match the greater than operator and the get line operator, and you're getting funny results. So let me show you a bug with what, if you're not careful, what this can do to you. Okay? Because this happened to someone on the current lab. So I'm going to do bug.cpp, and I'm going to say #include iostream using namespace std, int main, int points, string name, or string line. Now I'm going to say cin into points, get line, cin line, cout, line equals, line, end line. Okay, and what I'm going to do, just a moment, you'll see what I'll compile this. So let me get another window. Okay, it compiles. Now watch this. On the first line I put 10. So you expect it to read 10 into points. On the second line I am going to put, I never got to input a second line. Line equals blank. But wait a minute, I wanted my input, I say, wait a minute, I want my input to be 10 and, hi, my name is Brad. Think, okay, let me try to do that. Surely it will read and print out line equals my name is Brad. It didn't work. What happened? So it never finished up with the first line. Okay, it read what was left of the first line, which was nothing. Okay, so you got to be really careful and know what you're doing when you mix and match the greater than operator and get line. I recommend you don't do it right now because it's going to amaze and befuddle you. But Dr. Plank is an expert C++ programmer, so it doesn't amaze and befuddle him. He uses it to do magical stuff. Okay, but I'm telling you, if you try to do this, you may end up wondering what the heck happened. Okay, at any rate, he's reading the rest of that line, which gives him the rest of the name. So when he says name plus S, he's just getting the rest of his name. The rest of the name is an S. And he's setting that to score, and then he iterates through the golfer map, and because the golfers are in alphabetical order, it prints out the golfers in alphabetical order. And we're all happy right now. Okay, this is really just exactly what we want. Okay, so he now says this is quite convenient. What happens if we try to access a map and the key isn't there? And as I just told you, the answer is it inserts the key and it inserts it with a blank value in this case because it gives it the default value. So we're going to take a look at Tiger and Jack. Okay, Tiger and Jack Nicklaus being probably the two greatest golfers of all time. If you like Arnold Palmer, Sam Snead, or Gary Player, mucho apologies. Okay, first of all, I will back him up on this because Jack grew up in my suburb of Columbus, Ohio, Upper Arlington. And many of you may not know this, but he is called the Golden Bear. There are two reasons that Jack was called the Golden Bear. First of all, Jack was, shall we say, overweight when he was a young man. You may not know this because you see Jack looking thin. But when he was a young man, he was rather overweight. So he was called the Golden Bear because bears are big. But why was he called the Golden Bear? Because it is the Upper Arlington Golden Bears, my high school. So he was called the Golden Bear because he went to Upper Arlington High School. So my suburb, our pride of our suburb, Jack. Okay, actually, while we're at it, so I golf as well, and I remember coming at one point on the Ohio State golf course the first time I played it to this dogleg left par 4. And the person I was playing with told me, and apparently, whoops, it is a true story, this dogleg, let me just tell you, there is nothing, this right here is the Valley of Desolation. It is out of bounds, there are woods, you hit it there, you lose strokes. Jack didn't care. To Jack, he could hit it all the way over the woods, straight to the green on this par 4. He apparently routinely did this during his Ohio State golf career. Imagine how you would feel in match play if you were with Jack and he keys off and he knocks it on the green. You essentially concede the hole right there. Okay? So at any rate, I remember looking at it and thinking, oh my gosh, this is why Jack was one of the greatest golfers ever. I mean, that was a 300-yard carry. Not only was it a 300-yard carry, you couldn't just land it on the green because you can't control the spin. You had to leave it just short of the green and let it bounce up onto the green. Jack could do that. Okay, enough Jack worship. I'd tell you Tiger stories too, but Tiger's not from my suburb, so you don't get these stories. Okay, so the point of all of this is Jack did not play in the 2009, or I don't think he played in the 2009 tournament, Masters tournament. So what he is doing is, again, reading in all the golfers who played in the 2009 tournament, and then he is printing out the scores for Tiger and for Jack. And when he prints it out, Jack did pretty darn well. I don't know about you, but over 4 rounds at the Masters, 0 is an outstanding score. Okay? Come to think of it, it's an impossible score. The best score you could get over 4 rounds at the Masters is, does anyone who golfs know? 4 rounds? Come on. It's got to be a golfer. 4 rounds. 72. Very good. You'd have a hole-in-one on every single hole. So 0 is an impossible score. What happened? Jack didn't play the 2009 Masters. And when we printed out Jack's score right here, it inserted Jack into the map. And how do we know that? Well, he also printed out the number of golfers. So when he got to Tiger Woods, there was only 96 golfers in the map. After he printed out Jack and printed the number of golfers, there are now 97 golfers in the map. This is the danger part, is that when you try to find a key that does not exist, it will be inserted using this square bracket notation. So use the square bracket notation with caution, okay? Because it will, on a find, it will insert that key into the map if that key does not exist. So you need to be careful when you use it. As long as you are familiar with that caveat, go crazy using the square bracket notation. Okay? So that's why he said temptation, temptation. The other thing you have to be very careful about when you use it is it overwrites whatever was there before. Okay, so with temptation, temptation, what he did was in fact compute golfers' average over all 4 tournaments, the Masters, the British Open, the US Open, and the PGA. So what he did, he again calculated, he did a, he first of all declared this vector events. Then what he's going to do is he's keeping track of, for each golfer, the number of scores the golfer has. So every time he is finding the golfer, he's doing a pushback so that he keeps track of the golfer's score. So each golfer now has an integer vector, which is the number of scores for that golfer. Okay, so if you could see it as a picture, each golfer like Tiger has a vector, if, for example, we've only seen 2 of Tiger's 4 scores, the vector would currently be too long. Okay, so he does this read, he pushes back the scores, then he iterates through the golfers. If the size of the vector is 4, he knows that the golfer participated in all 4 events, and he goes and computes their total by summing up their 4 and then dividing by 4, and he prints it out. So you'll see that Adam Scott averaged 302, Alvaro Quiros averaged 302, some other players and their score and their 4-round average all print out. Okay? So now what he wants to do is sort by the best scores. He wants to know who over 4 rounds, or 4 tournaments rather, had the best scores. So he wants to sort by the lowest score. Okay? So he's going to create a second map where he can store his averages. So there, he's sorting by the average. So the key is the average and the string is the name of the golfer. Okay, so he's going to, after he computes his average, he's going to insert that golfer into the map by average. So the average over 4 tournaments, we're keeping them in sorted order. And he then prints out the averages. And he prints them all out, and we see Ross Fisher. Who ever heard of Ross Fisher? Someone raises their hand and says, I'm Ross Fisher's brother or sister. How dare you? But that's not happened ever. So I continue to say, who the heck is Ross Fisher? Okay, but that's right. Hey, how dare you? At any rate, Ross did better than some of our big names like Lee Westwood, Rory McIlroy, Vijay Singh, or Jim Furyk in 2009. You may also be stunned if you follow golf to see that Tiger Woods, who was doing pretty well in 2009, is not on this list. In fact, Tiger Woods should be on this list. He played all 4 majors, and here is Dr. Plank. But where is Tiger Woods? Certainly he would be in the top 10, along with Dr. Plank's editorial about Tiger Woods. Okay? So, in fact, Tiger Woods averaged 287. Yet, VJ has printed out, but there's no Tiger Woods. What do we think happened? Why isn't Tiger out there also with 287? Well, let's think about this logically. We're using a map, not a multi-map. How many duplicate keys can we get into a map? 0. So if Tiger Woods went into that map first, which he did, he originally was in the map with a 287. But then what happened was VJ came along and also had a 287. So when we got to VJ clobbered Tiger's entry. It updated the entry. So VJ showed up in the output, but there was no Tiger Woods. The moral of this story is we can't use a map here. We'd have to use a multi-map because we need to store multiple values. And multi-maps also don't let you use this notation. Why don't you think a multi-map is going to let you use that notation? You're going to have to use dot insert and dot find. Very good, because if you use this value, it is ambiguous in a multi-map. Do you mean to update an existing entry, or do you mean to create a new entry? If you're in a multi-map, if I say in a multi-map, I say M A equals M of X, and there's duplicate keys, which value am I supposed to be pulling? So multi-maps don't let you use this notation, this square bracket notation, because it's ambiguous. So not allowed in a multi-map because of ambiguity. Because it's ambiguous. Okay? So you can use square brackets with sets and sets and maps. You can't use it with multi-sets and multi-maps. What you get, by the way, when you do a find in a multi-map is an iterator to the first value or first key in the multi-map. And then you can iterate through the remaining keys that are duplicates to get all of the values associated with that key. Okay. Now, let's take a break for a moment. And I've been telling you that maps keep things in sorted order. Let's just peek under the hood for a moment. We'll get back to it eventually at the end of the semester. But how does C++ actually manage to keep things in sorted order in a map? So here's the sneak preview. It uses something called magic. I like that. It uses something called a binary search tree. Okay, we will get to them at the end of the semester, but let's say that we insert 30. I'll just draw it out. 20, 80, 10, 25, and 100. What a binary search tree does, it looks like a tree, actually an upside down tree. And the children, there's only at most two children. There can be one child, 0 children, so 100, 10, and 25 have no children. 80 has a single child. 30 and 20 have 2 children. If you have children, all keys that are less than you go in your left, what we call subtree. All values that are greater than you go in your so-called right subtree. So, if we are trying to find something, like say 25, 25 is less than 30, so we know that it's in the left subtree, so we go to 20. 25 is greater than 20, so it must be in the right subtree, so we go to the right subtree, and voila, there's 25. You'll notice that there are 1, 2, 3, 4, 5, 6 keys, and yet there's only 3 levels. So that is, if it's well balanced, if there's n keys, there will only be roughly log n levels. So if it's balanced, then there will only be log n levels, where n is the number of keys. That's why we get the log n performance. Because we only have to ever go and examine one key at each level. If we're looking for 25, we never have to, we eliminate the right half of the tree. We know that 25 must be in the left half of the tree because all keys less than 30 are in the left subtree. Okay, and it keeps it in sorted order because you can traverse this tree in a certain way, which again we'll get to, that allows you to produce these items in sorted order quite easily. So that's a look under the covers to see how it's implemented. Don't worry about it right now. I just want you to know how the magic is done. But we'll get back to that magic after we've gotten through a topic called recursion, because without recursion, we can't really talk about how these trees get implemented. Okay, back to what we've been talking about. So, let's do a quick review. First of all, with sets and maps, sets, what's the difference between a set and a map? So with a map, you can store a key value. With a set, you can only store a key. Okay, what is a multiset and a multimap? How do they differ? Don't be shy. That's right. Okay, duplicate. Yes. Pardon? Go ahead, Rachel. What? They're duplicates, so they can store duplicates. Okay, can store duplicate. Okay, so if you need duplicates, you use a multiset or a multimap. Okay, the big operations: insert, delete, find. Okay, and insert, delete, and find are guaranteed. Insert, find, delete. Guaranteed order log n. All of them are guaranteed to be order log n. Guaranteed in the C++ implementation. Okay? Now, last thing. We just did something where I wanted to print out the golfers, and I wanted to do it. I took their average over 4 tournaments. Then I printed out the golfers in sorted order by their average. And I used maps. This is fine, but it's not the most efficient solution. Remember, in this course, we want you to think about efficient solutions. This isn't the best way to accumulate scores for golfers. Okay, because every insert is going to take us log n time. And we're not using a range query, we're using a point query. If we use a point query where we're simply inserting and we don't need to keep something in sorted order, what is a better choice? Okay, vector doesn't work because we have to find them. Okay, so a vector would be order n because of the search. How about a hash table? A hash table takes order 1 time to find and insert. So instead of using a map, we could have used an unordered map, i.e. a hash table, to do this operation. And instead of every find or insert taking log n time, it would take order 1 time. I'm sorry, I should have been, this was it, the pushback. Okay? I could have used an unordered map. So in fact, I did that. The notes, a better solution using hash tables and vectors. So I used an unordered map rather than a map. I didn't even have to change this code. The code still does a pushback and uses the square bracket notation. It's just I'm using a hash table rather than a map. And now I have up to 4n inserts. Okay, again, I'm using Firefox, so I can't quite do it. Let's change over to Firefox. Okay, so I'm doing 4n inserts right here. So there's 4n inserts. With a hash table, those 4n inserts take 4n time. With a map, they take 4n times log n time because each insert takes log n time. So the hash table takes less time to do our inserts. And we don't care in this loop where we calculate the averages whether the golfers were in sorted order or not. It was immaterial because we wanted to simply calculate their average. We didn't have to keep them in order by last name. We wanted to calculate their average, and we wanted to sort on average. So you might say, okay, Brad, let's keep a map in this case. No, 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 no. Let's use a vector. So we're going to push onto our vector pairs where the first item is the average and the second item is the golfer's name. And then we're going to use the sort method. Remember, you can sort a vector, and we're going to sort the golfers. Okay? And we had to do one thing there, which is that when we did our comparison, we had to tell we had to provide a compare function which takes two values which are both pairs, and we want to compare the first values, which are the averages. So if golfer 1's average is less than golfer 2 average, we return true, otherwise we return false. So it needed to be able to have a comparison function, and I'm pretty sure that I needed a third argument here, and I somehow left it off because somehow it needs to know about that function. So I'll look at it, but I'm pretty sure that right here I needed a third parameter that was golfer compare. Okay, but at any rate, the point is that I could do the sorting and the inserting more efficiently using hash tables and vectors. So when you're designing solutions to problems, you really do need to know the running times of these different algorithms, okay? Because if you don't, you are doomed to creating inefficient solutions. Okay, so remember Thursday, no regularly scheduled class, but you have a video lecture on pointer structures that you will be expected to watch.